Welcome to a lesson with Dr. Powell. Let's take a look at what is called a binomial series. It all starts with what we already are familiar with polynomials. If I take 1 plus x and raise it to a power, like 3, say, another way of thinking about this, at least naming the coefficients, is as follows. 3 choose 3, x cubed plus 3 choose 2, x squared plus 3 choose 1, x plus 3 choose 0. Now, the definition, or one way of thinking about this, actually comes from taking derivatives a little bit itself, which means that we can extend it even when this 3 isn't a whole number, or it can be negative, or it can be a fraction, or whatever. This same idea will hold. This 2 is important because it tells us we have a fraction with 2 things on the top and 2 things on the bottom. Here we have, on the bottom we start at 1, so 1 times 2. On the top we start at 3. 3 times 2. And this is the definition you could take it for this symbol, 3 choose 2. Now, notice what's happening. We start with 3 and we go down by 1. And we have 2 factors on the top, 2 factors on the bottom. Well, can't we do something similar in another situation? Even when we don't start just at 3? This idea works because, think about it, if we take 2 derivatives right here, then what's happening, a few things are, if we take 2 derivatives of this, say, and this over here on this side, let's see what happens. Take 2 derivatives over here. We have 3 times 2, 1 plus x to the first power. Using chain rule, the inside has derivative 1. Over here on this side, these things go away, and this becomes the constant term after multiplying by 2 times 1. So we end up getting 3, 2. 2 times 1 is the constant term. And then when we plug in 0 to both sides, everything else, especially whatever this is, goes away. And over here, we have a 0. So we end up, in solving this, we end up getting 3 times 2 over 2 times 1. Now, think about where this came from. This came from right here, 3, and then 3 minus 1. The same thing can hold even when this 3 is something else. Okay, so in general, we have, suppose we replace 3 with just k, and maybe we say k choose 2. Couldn't we do something like k times k minus 1 and 1 times 2, where k is not necessarily an integer, and this should be the coefficient of x squared. In a Taylor series. Expanding this idea, we have the following. If we take 1 plus x and raise it to the kth power, we end up getting a series from 0 to infinity of k choose n, x to the n, just like that. So where this is defined similarly to what we did up here. And in general, let's think about this. K choose n should be a fraction with n things on the bottom and n things on the top multiplied together. Notice how we have 1 times 2 times 3. In fact, we can even just think of that as being 2 factorial. So in general, think of this as being n factorial. On the top, let's we start at whatever k is and just have n things on the top multiply together, subtracting 1 each time until we've subtracted off n minus 1, because at that point we have n factors, because this is like k minus 0, k minus 1, 2, all the way to n minus n minus 1. So this really is the definition. For instance, let's do 1/2, choose 3. What would this be? This would be a fraction, 3 things on the bottom, 3 things on the top, starting at 1 on the bottom, 1 times 2 times 3 on the top, starting with 1/2, subtracting off 1. So -1/2, subtracting off another one, -3/2. And we could perhaps simplify this a little bit. That 3 cancels with that one. Negative negative would be positive. So we have 1/8 divided by 2, so 1/16. Positive 1/16 is what this coefficient is. 1/2, choose 3. Thanks for watching.